Next, we have a very interesting problem. So this is we can call this smart athlete problem, or these are normally called two medium problem. So you will understand why we call two medium problem. So what it says, an athlete has an option to either run along a beach. So you run along a beach with a speed of 120 meters per minute, or swim with a speed of 30 meters per minute. These numbers may not be exactly like accurate. I just pick some numbers just as a math problem. So if he sees an object 90 meters off the shore, so let's try to understand what they mean. 90 meters off the shore and 100 meters ahead to the nearest point of the shore. So 100 meters ahead to the nearest point of the shore. So that means, so this is a situation as a shore. So you're going to see an object somewhere here. So it says 90 meters off the shore, and so this is where the athlete is. So it's going like that. So this is 100 meters here. So that's the situation. So it's 100 meters ahead and 90 meters off the shore, but that's where the object is. Okay. So, and then the question is asking how fast does he need to run? Because the first he need to run before he swims to retrieve the object quickest. So that means we try to make the time minimum. So what we do is, so you can run first and then you're gonna go swim. So that's the kind of situation. First run and then swim. So so let's try to introduce some variables and see like how we can solve the problem. So let's draw a situation now. So this is a show, and then this is the object. So we have the athlete now. So it says 90 meters off the shore. So that's the 90 meters. 90 meters off the shore. And this is 100 meters ahead of him. So that's the situation. So let's say so he walk first and then swim. So we're going to consider this distance as x just to make the algebra easy. So then you're going to get 100 minus x here. So this part is 100 minus x. Now from geometry you can see that from Pythagorean identity. So the length of the hypotenuse you can write as x squared plus 9 squared square root. That's from the Pythagorean identity. And then we also know the speed. So we know that he can run with 120 meters per minute. And he can swim 30 meters per minute. Again, these numbers may not be very accurate. Okay, so that's the situation. So now let's start calling some variables. So we can say let x be as indicated in the figure. If you try to explain that take time. So and then after you do that, then he runs. So you can see he run how much? 100 minus x before he starts swimming. Before starts swimming. Okay, so now we're going to recall some of the familiar formulas. So we know that. So notice that we know this formula. Speed equal distance over time. So that means so you can say time is the distance over speed. distance over speed. So we can use that formula now. So because of that, so if you know the distance and if you know the time, then you can write the total time. So in this case, you can write the total time. So there are two time. So so the one he run would be we can call it T1, which is, so he run 100 meter minus x with the speed 120. So that's the time that need to run. And then on the other one, you can see that it is x squared plus 90 squared square root divided by 30, because that's the time. So we can call this T2. That's the time it's going to swim. So that means the total time. So you can say the total time. So total time, which is T1 plus T2. We can call this like T x, because it's a function of x. So it's the sum of the two, so which is 100 minus x over 120, that's the first one, plus x squared plus 90 squared square root divided by 30, that's the second time. So that's the total time. Now what you can do, so that's the formula we are looking for. So we get the formula. And then also you can see that the numbers that we have. So we can on 0, x equals 0 to largest value x is 100. So that's the two values that we have. Now what we can do, as usual, we can find the derivative of this one. So this is the t prime x, because we are trying to find the critical points. So it's easy to find the derivative because you can ignore the constant. So you can just say this part. So that means if you look at that part, so derivative is going to be 1 over a negative 1 over 120. That's the first part. For the second one, you can write 30 in front, and then this is a square root, that means 1/2. So 1/2. So you have x squared plus 90 squared negative 1/2 times 2x, because this is by the chain rule. And then you can see this 2 and 2 get cancelled out. So if you simplify this one, what happens if you simplify? So you can see you can take the common denominator. Common denominator is 120, and then also you can bring x squared plus 90 squared down. So what we can do is you can multiply the top and bottom by x squared. So the whole expression, so the entire expression, you can multiply the top and bottom by x squared plus 90 squared positive square root. That's how we can do. So we're going to multiply the whole expression by this x squared plus 90 squared square root, the top and the bottom. So when you do that, you get 4x minus the square root term. So you get x squared plus 90 squared square root for the numerator. For the denominator, you get the common denominator, which is 120. That's one term. The other term is x squared plus 90 squared square root. So now what you can do, so that's the derivative, and see whether you can get that. This is not that difficult. And then you set this equal to 0. So once you set that equal to 0, you can see the denominator cannot be 0. So it can be 0. So only 0 is coming from the numerator. So you're going to get, so you have 4x minus x squared plus 90 squared square root equals 0. So in other words, if you move the term to the other side, so if you move this term to the other side and then in square, so you're going to get that 16 x squared equal x squared plus 90 squared. That means 15 x squared equal 90 squared. 90 is, you can see, which is 6 times 15 times 90. So that means you can cancel the 15 term. So you get x squared equal 6 times 90. That means if you take the square root, so you get x equal, because you can say 90 again, 6 times 15, that means it's going to be 6 square root 15. So this is like approximately 23.23. So that's what it approximates. So that is so that's x value. So that's x value means So you're gonna run 100 minus x and then you assume the rest. So let's see. So we get that value. Now let's see whether this is a minimum. If this is a minimum, then we can do this. So to find whether this is a minimum, I mean you have multiple ways. You can use the first derivative test or the second derivative test. So let's do the second derivative because we just take the derivative. So if you do that, so first you notice that the derivative is it was negative 1 over 120 plus. So we look at the this form. Because it's much easy to take the derivative because some of the terms get cancelled out. So you're going to go back to this form and try to do the derivative. So once you take the derivative of again, so you can see the double derivative. So you can see the first term is 0, is a constant, and then we use the product rule. But when you use the product rule, you can say 1 or 130, you can take it out, and then use the product rule, which is we know that the u prime v minus v prime u over v squared. So that's a formula. So we're gonna use that. So that means u prime, which is 1, and then x squared plus 90 squared square root minus, now we take the derivative of the second term times x, so it's x times the derivative of the second term, which is 1/2 x squared plus 90 squared negative 1/2 times 2x divided by square of the bottom term, which is x squared plus 90 now, because we take the 1 over 30 out. Okay, so that's what you get. Now you can see how to simplify this one. Again, you're going to multiply the top and bottom by this term. You're going to multiply the top and bottom by this term. When you do that, you can see this term get cancelled out. This become 1. So, and then also the 2 and 2 get cancelled out. So we don't need that. So you get x squared on the other side. So that means you will end up getting this. So you will get at 1 over 30. You can still write that as a term out. So you can see that this side going to be x squared plus 90 squared. You directly get that as the first term. Square will get cancelled out. Minus, on the other one you can see the negative square root term get cancelled out, so you simply get x squared. That's what you get over x squared plus 90 squared, and then you can see x squared and x squared cancel out, so this simply become positive now. Actually bottom is 3/2 because you have another square root term, so it becomes 3/2. Now you can clearly see that this is positive, so this positive means has a minimum. So has a minimum by the second derivative test. So second derivative test has a minimum. So that means that's exactly what we need. So we can finalize the problem now. So we know that there's a minimum at that critical point. So the critical point is this one. So that means we can finalize it like this. So we can say, so he runs. See, he runs 100 minus x, which is 100 minus 23.23, actually approximately, which is equal to 76 minus 76 meters before he starts swimming. Starts swimming to minimize the time. Always make sure that you write this line just to finalize the problem. Okay, so this is how you use calculus to solve an applied mathematics problem.